Okay, so in this section, we'll see how does a complex number look like. Okay, so what is a complex number? We'll just briefly, we'll try to get the idea of a complex number. So far, we have worked with only real numbers, set of real numbers, starting from negative infinity to infinity. We have taken all possible numbers, fractions, decimals, rational number, irrational number, everything, right? Positive and negative, whole numbers, zeros. But this time, we want to see how does a complex number look like. So first of all, uh, for a complex number, you need one imaginary unit, okay? And that is called I. If you remember, we did say in real numbers, in the set of real numbers, we don't really allow negativity inside the square root sign or any even root. Okay, if you have any root like this or in this format, if n is even, we don't allow negativity inside it, but that's true for real numbers only. For complex numbers, we do allow negativity. Okay, and for that you need to have an imaginary unit, which is this. So we actually define this negative inside the square root, inside the root, as I. Okay, that's your imaginary unit. All right. So now the question could be, how can you define a complex number? How can you write it? So a complex number is of this form, a plus ib. Okay, where a is a real number, b is a real number, and I is, of course, the imaginary unit, which is square root of -1. So a complex number will always be in this format. If I give you an example, it will look like this. So let's say 2 plus 6i. Okay, a complex number will look like this. Whereas you have seen the real number, which looks like this, right? 2, 6, 6,000, -8, etc., etc., right? But for a complex number, it has to have this format. So that's what you need to remember. That's what you. That's how we define a complex number. If you remember this, then we can actually move on. Then we can find some new properties. How can we add to complex numbers? How can you subtract to complex numbers? Multiply, division, finding roots, and all that. Okay, we'll just see the basic idea of these complex numbers. So first of all, a complex number, as I said, is of this format. Okay, if you add another complex number with it, let's say c plus id, that's a complex number as well. Now if you want to add it, the idea is you need to, if you remember from Math 95, even when you got the idea of adding two real numbers, it's the same idea, to be honest. You need to combine the like terms. Okay, so that means we'll add the terms without I and we'll add the terms with I. Okay, that's the idea. Pretty simple. So it will be a plus c and b plus d. As you can see, it still has this format, a plus ib. It looks like that, right? So that's a complex number as well. If you add two complex number, it will definitely remain a complex number. And simply because any real number is actually uh, uh, can be expressed, you can express a real number as a complex number. It's a funny thing. For example, 6, it's a real number, right? But you can always rewrite it 6 plus 0 times I, right? And it's a complex number, you can see. So the idea is, the big picture is, let's say that's the real number, that's a ping pong ball. You can always put a ping pong ball inside a basketball, right? Like this. So let's say that's a basketball, or that's a soccer ball, okay? And that's a ping pong ball, table tennis one, the smaller one. You can always put it inside, right? So this is basically the set of real numbers. And the bigger one is basically the set of complex number, which we see write as C, okay? That's the set of complex number. So the set of complex number actually contains all the real numbers as well. Oops, who's in the background? All right. Okay, so that's the idea. Okay, you can always express a real number as a complex number, but not the other way. Okay, it may not be for the other direction. All right, so if I show one example of adding, of course, it will make more sense, hopefully. So 3 plus 5i plus minus 2 plus 3i, combine the like terms, right? So the terms out I, and then comes with I. So it will be 5 plus 3 plus 8 Can you hear me now?